Hello again, Tom from Every Step Calculus, everystepphysics.com. If you want to, you can click on the icon on the bottom right of this screen, to subscribe to my channel for future hate on calculus comments by me, and with my step-to-step solutions to the, useless real-life problems. This here on your screen is a problem I got off the internet, actually from a YouTube, where I searched polar double integrals, and I decided to show you how my programs work on this problem. You can go to yourself and see it, and see how the professor works this problem. To me, he leaves off important stuff that students need to know, as usual, because a lot of those simple things that at the beginning of a problem are elementary to him, and he just gets tired of teaching it or bored of his job or whatever, and he assumes that we do know it, and of course we don't, and so it takes us like an hour to say, how did they get from that step to this step, the setup double integral problems, which they are setups, because you notice even if you change a minus sign in a problem, it's completely different in calculus. Like for instance, this is a difference of squares here in this square root of 4 minus y squared, and when you factor difference of square, you get 2 minus y times 2 plus y. But you put a plus sign in here, and it's a totally different problem, okay? It doesn't match the Pythagorean theorem, which of course this is, and I'll get into that in a second here. I do the conversions in my program, but I don't do the limits on these problems, because most test problems give you those. So I'm going to teach you how to do those in this video here. These are all Cartesian coordinates, x and y coordinates in this problem, and f of x and y, and or z is the function. And let's get started a little bit here. Index 8 to get to my main menu. I'm going to press enter. I'm already at polar double integral. Now in a test, they're going to say, hey, change this double integrals to polar before you do it or something, so then you know that it's going to be polar, so then you go to polar double integrals, and that's my program for that item, And you're supposed to write this on your paper. Make sure that you write it in not really clean, because you have to look like you know what you're doing on these problems. And of course, nerds and professors always write sloppily, because they want to make sure that you know that they're geniuses at these problems, can do them in their head, and it's just a waste of time to mark anything down on a sheet. So then therefore they just do it really fast and really bad characters. So you do the same, so that you look like a genius on this stuff, evidently, Now I have R1 and R2 for radius 1 and radius 2, and then theta 1 and theta 2 for the theta integral. Okay. So make sure you use your professor's characters in these situations, so that you don't look like you're copying or whatever you're doing. And the professor might have z in here. Well, then you have to put a z in here when you're doing the problem, okay? Let's go to the next screen here. This is the system of changing from Cartesian to polar. You notice x squared plus y squared equals r squared, okay? Well, this is Pythagorean theorem again, except with different characters. Pythagorean theorem is a squared plus b squared equals c squared, r squared being the radius. And so keep that in mind. All these things are really a lot of Pythagorean theorem in calculus, because there's exponents, x squared and c squared and things like having an exponent, and of course calculus salivates over that stuff because they got an exponent to do their differentiation and integration with, So a good thing to keep in mind is that if you ever see changing a polar, you see x squared plus y squared, which will always be, because that's part of the setup problems that they give you, you're going to change that to r squared right immediately. Okay? So this is going to become 1 over the square root of 1 plus r squared. Calculator will change this to r squared plus 1, same difference, okay? dx dy is changed to r dr d theta. That's the order of integration. You can change it around to r d theta dr, which I give you the option in my programs. You never know what they're asking. dy, and these are always the d theta integrals. dx is always the radius integral. dx is the inside integral, so here's the inside limits for that. Here's the dy is the outside, here's the outside limits for that. Okay? So it's a good idea on your paper to mark this down too. Remember, you get, partial credit in the class curve here for calculus and physics programs because they're so tough, classes. And so whatever you mark down on a problem that's kind of pertinent to that problem, you're going to get a 2 or 3 points for it, whatever, I remember one time I got a 26 on a physics test. I thought for sure I'm going to flunk it, and I got an A on the test. 26, showing that the class was pretty lame, Also now, a good idea is to memorize this drawing here, because the test problem might have you draw this, okay, draw something like this. Well, if this was 4 minus x squared, which could be very easily square root of 4 minus, and you graph that on your calculator, y equals 4 minus x squared, it turns into a half circle, okay? So if you ever draw these diagrams, like I say, and you don't know what to do, just put on your paper, a vertical axis for y and horizontal for x. Immediately draw a circle like this, half circle above the x-axis, and then you can put the radius in here, which is 2. They get the radius because the square root of 4 is 2. So you don't even have to do the calculation. You can just look at this 4 here, and half of that, or the square root of that, is going to be 2 for the radius. So you put 2 up here, 2 there, and there you got a drawing, got 3 points on the problem, okay? It's a little bit more complicated for this square root of 2 for the theta, and he gets pi over 4. You're going to have to convert that to polar, which is pi over 4. This comes from the unit circle, which is in the back of your calculus book. There's this whole circle with degrees and pi's and hypotenuses of what goes on in that unit circle. The reason they call it a unit circle is because it's based on a right triangle, and the base is 1, and in the opposite side is 1. So you have a 1 and then 1, for the... And of course, when you do a squared plus b squared equals c squared, you take 1 squared plus 1 squared, which is 2 squared. That's the hypotenuse. And c squared equals 2 squared, so then c is equal to square root of 2. So that's how they get that. Okay, now let me show you how they get the pi over 4. In a unit circle, on this side over here, this is 360 degrees and 0. Okay? It's also 0 pi. So when you go half circle on the unit circle over here, that's pi, and you go complete the circle, that's 2 pi, 2 times pi, okay? Well, if this is pi over here, that's a half a circle, well then this is half of that, right? So this would be pi over 2 for 90 degrees, right? And then square root of 2 is really an equilateral triangle, as the base and the height are the same, and so then the hypotenuse is 45 degrees. Okay, this is kind of basic stuff, I guess, in geometry and stuff, but anyways, 45 degrees here, so then that's going to be halfway there, and so that that's 45 degrees. Okay, so then half of this pi over 2 and 0 here is half of that, which is pi over 4. So that's how they got that, okay? We turn the simulator on again. So let's go further with my programs, okay? To enter the function here, f of x and y, in here you're going to have to press alpha first, okay? And then you do whatever it takes to put these characters in there, you know, which is pretty easy. Now I've already done that to save time and to make sure that the simulator doesn't screw up because it's such small here and you're pressing these buttons with the cursor. So I've entered that. I always give you a chance to change it. I say it's okay. And we're going to change the polar. Now here I've changed it to polar. That's 1 over the square root of r squared plus 1, which I just talked about. We changed x squared plus y squared to r squared, right? So there it is there. You're writing this all on your paper. Order of integration is dr d theta. Okay, so we're going to choose that one. And here's the formula again for this dr d theta, okay? If you wrote it before, then you don't have to write it again, I guess, you know. And we're going to enter the radius, what's been found here. We have to press alpha first, and the radius is 0. And alpha 2. I show you what you now notice the 0 here. They have y in here, but y is equal to x, and of course the reason that x a radius is always 0 on these problems, unless they tell you different, where they're doing 2 circles and give you a different radius. The center of a circle is always 0, okay, for a radius. So you know that it has to be 0 unless they tell you something different. So even though they put y here kind of to throw you off, just like they put y squared here instead of x squared, professors and people love to throw you off and make it more difficult for you, you know, whatever they can do. See if you really know what you're talking about. And so now we're going to enter the theta 1 and theta 2. Okay, that's 0 and, this, and pi over 4. So we're going to press alpha 0 and alpha second pi divided by 4. Show you what you've entered. You can change it if you made a mistake. We say it's okay. So I show you how these limits are. Here they have the d theta here, pi over 4 over 0, and 0, and the radius is 0 over 2. And we have what we changed here for 1 over the square root of r squared plus 1 in there, okay, for the integral. Now one of the big tricks that everybody forgets about is you got to multiply this r and r times the inside of that. So we did that, which turns out to be r on the top there in the numerator. And here's the new problem, r divided by, instead of 1, it's r, square root of, etc., etc., okay? We're going to integrate with respect to r, which is this, and with the limits of 2 and 0, we're going to, so r2 equals 2, the dr is equal to the square root of 5. r1 at 0, dr is equal to 1. Upper minus lower of those limits, square root of 5 minus 1. And we have a new integral now, square root of 5 minus 1, with these limits, the d theta integral. Integrate with respect to theta. Turns out to be theta times square root of 5 minus 1, quantity, and with these limits here. So at theta 2 is pi over 4. That turns out to be square root of 5 minus 1, the quantity, times pi over 4. And at theta 1 being 0 equals 0, upper minus lower. And so the answer is volume is equal to square root of 5 minus 1, the quantity times pi over 4. If you multiply that out, it becomes 0.971 cubic units. Now notice most professors, when you look at YouTube or anything, I've never found one of them that does this, where they say what it is, volume is equal to cubic units. And they never do that. They just put down the answer and that's it. But remember, calculus is just nothing but Sudoku problems or crossword puzzles. And very difficult, but useless in real life, you know, waste of time actually. So anyways, pretty neat, huh? Now we could, or let's do it. You want to do it? Let's do it. Let's go to the new problem. Let's get put the function in here again. And let's convert it, which we did here. And let's do it the other way. Theta, you know, with the reverse the integration. Now we got d theta dr, which is going to be more difficult to do. And the same system, we're going to enter the theta ones. That's theta 0 and alpha pi divided by 4. I say it's okay. The radius is alpha 0 and alpha 2. Yep, correct. So now we've reversed everything. This is a different story now. And we're going to do the same thing. Gets more complicated. With respect to theta equals 0, really, theta. And with these limits here, pi over 4. And the answer to that is pi over 4 divided by 4 times the square root of r squared plus 1, okay. Lower limit, upper minus lower. It's a new integral. Look at the integral here. And with respect to r, here's the answer to that. Upper limit 2, lower limit 0 equals pi over 4. And so we get the same answer, square root of 5 minus 1 times the quantity times the pi over 4 and 0.971 cubic units. So pretty neat, huh? everystepcalculus.com, everystepphysics.com. Remember, I don't teach, I teach you how to solve tests, how to do tests. That's all I'm interested in. So that you can get out of there and never to touch calculus again. Even if you work at NASA, you'll never touch calculus. Totally useless problems. But anyways, go to my site and of course subscribe to my site if you will. That can help me. You'll notice if you go to YouTube, this problem here has about what 10,000 views, and you watch after I put this on the internet. After 3 weeks I'll have maybe 5 or 7 views. I don't know why. I think that YouTube shuts me down a little bit because I'm so negative about calculus, you know. But whatever. Go to my site, buy my programs, and have them for the rest of your life in your calculator. Don't ever throw the calculator away. Throw your book away, that's for sure. And have a good one. Good luck in your classes. And then, of course, you can call me and you can send me your tests or quizzes, and I'll show you how my programs work, you know, after you buy my programs. So you get a lot of benefits of buying my programs. You know, you get my fabulous help, and I know everything about calculus, really. And so anyways, good luck in your classes. Have a good one.